Welcome. In this video, we are going to see the properties of matrix addition. Now, what are these properties? The very first property is commutative law. Now, what is commutative property? Now, suppose in general, addition in the natural number is commutative. What we get about the commutative law? Commutative law means what? If we add 2 and 3, the order doesn't matter. 2 plus 3 is 5 and 3 plus 2 is 5. Okay. So likewise, if two matrices are there, A and B, and they have the same orders. Okay. Suppose A is a matrix Aij whose order is m by n, and B is another matrix B that is equal to Bij and whose order is m by n. Okay. These two matrices are given, and if we add these two matrices, that is A plus B. So A plus B is what? It is Aij plus Bij, and both the matrices have the same order. A plus B will be having the same order, that is m by n. Now these are the two numbers, and for the natural numbers, addition is commutative. So order doesn't matter whether we first write Aij or Bij, answer will be same. Okay, so I can have Bij plus Aij as the number in natural numbers, and the addition is commutative. Not in natural numbers only, for the real numbers. For whole real numbers, addition is commutative in the real numbers. Okay. So Bij plus Aij, this can be written like this, and the same order will be having the same order. So it is equal to what? You can write it as like this: Bij having n by n order plus Aij having n by n order. And so this will be having Bij means what? This is B and this is A. This is A, this is B. And so A plus B is equal to B plus A, and this is a commutative property. So matrix addition is commutative. Matrix addition is commutative. You can take one example also. Matrix addition is commutative. For example, a simple example we will take. Suppose A is a matrix, suppose having 2, 3, minus 1, 5, and B is another matrix having elements minus 1, 0, 5, 6. Okay. If we add A plus B, what we get? If we add A plus B, what we get? That is equal to 2 minus 1 is 1, 3 plus 0 is 3, minus 1 plus 5 is 4, 5 plus 6 is 11. And if we add B plus A, what we get? Minus 1 plus 2 is 1, 0 plus 3 is 3, 5 minus 1 is 4, and 6 plus 5 is 11. So both the answers are equal, and so the commutative property is satisfied by the addition of two matrices. So matrix addition is commutative. Now the second property is associative property. That is associative law, associativity, you can see. Associative law or associativity. Now associativity, what it suggests? Now as usual in the real numbers, addition is associative. Okay. So similarly in matrices, suppose A is a matrix having denoted by Aij having order m by n. B is another matrix having the same order given by Bij having order m by n, and C is a third order matrix having the same order m by n, and these three matrices should have the same orders. Okay, now if suppose A plus B, if we add these two matrices and then add C, then what happens? So it will be Aij plus Bij and plus Cij. Okay, now these two matrices are there. This is one matrix and this is another matrix. So Aij plus Bij will be plus Cij. You can write it like this, and you can bring these two elements together and keep this one as it is. That is Aij plus Bij plus Cij. As in real numbers, these are all the real entries, and in real numbers, associativity property is satisfied by the addition, and so this addition in the real numbers is associative. So you can do like this. So this will be equal to, if we separate it, Aij plus Bij plus Cij. So what is this? This is matrix A plus matrix B plus matrix C. So if we add these two matrices and then add the third one, or we keep first matrix as it is and add the second and the last matrix, and then we add first matrix, the answer will be same. So matrix addition is associative. So matrix addition is associative. Matrix addition is associative. Now you can take one example for that also. So associative law, that is A plus B plus C, that is equal to A plus B plus C. Now for example, I had taken three matrices having order 3 by 2. A is this, B is this, and C is this. Now if I add first A and B and then add C, so what will be the result? Now all these matrices are having the same order, so we can add them. So A plus B as usual, 2 minus 1 is plus 1, 3 minus 3 is 0, minus 1 plus 1 is 0, 6 plus 5 is 11, 4 plus 6 is 10, 1 minus 2 is minus 1. So this is a 3 by 2 matrix, and C is a 3 by 2 matrix, that is 6 minus 4, 3, 1. Okay, now we can add these two matrices. So what is the result? 1 plus 0 is 1, 0 plus 5 is 5, 0 plus 6 is 6, 11 minus 4 is 7, 10 plus 3 is 13, minus 1 plus 1 is 0. So this is A plus B plus C. Means we first add A and B and then we added C. So its answer, I will write it here, 1, 5, 6, 7, 13, 0. Okay. Now I will first do the addition of last two and then add the first one. That is A plus B plus C. So what is it? A is what? 2, 3, minus 1, 6, 4, 1 plus B plus C. We can add directly. Minus 1 plus 0 is minus 1. Minus 3 plus 5 is plus 2. 1 plus 6. 1 plus 6 is 7. 5 minus 4 is 1. 6 plus 3 is 9. Minus 2 plus 1 is minus 1. So if we add these two matrices, that is A is as it is and B plus C is the resultant matrix is here. Both the matrices are having the same order. So you can add their corresponding elements. So 2 minus 1 is 1. 3 plus 2 is 5. Then minus 1 plus 7 is 6. 6 plus 1 is 7. 4 plus 9 is 13. And 1 minus 1 is 0. Now, if we see these two matrices, both the matrices are equal. That is, the entries in all these entries are same. And so, we can say the matrix addition is associative. So, A plus B plus C is equal to A plus B plus C, provided all the three matrices should have the same order. Additive identity means what? If in general, if suppose A is a number and if you add something, then we get the same answer. So what is this? This is the additive identity. Now in general, for real numbers addition, what will be the additive identity? What do you think about it? Can you think? Okay, so you are using that. So this question mark should be filled by 0. Okay, so if we add 0 to A, we get the same answer. So this 0 is called the additive identity. So likewise in the matrix, 0 matrix of the same order as given by as that of A, the given matrix, will be the additive identity of the given matrix. Okay, so 0 0 is the additive identity. 0 matrix. Okay, now what is 0 matrix? Now you know 0 matrix is having all its entries 0. All the elements of the 0 matrix are 0. Suppose A is a given matrix and Aij having order m by n. This is a given matrix. Then 0 whose elements are all zeros, all are zeros, is a additive identity. So existence of additive identity. This is the third property. Suppose let Aij is a given matrix of order m by n and 0 is the 0 matrix of order m by n, the same order. Then A plus 0 means if we add this 0 matrix with the A, this matrix, then we get the same matrix. Okay, so this 0 matrix is called the additive identity. It's called the additive identity for the addition of matrices. Okay, so 0 matrix is the additive identity for the matrix addition. Now existence of additive inverse. Additive inverse is what? Suppose A is a given number, okay, and if suppose in general, what we get, what is added in this, and we get the additive identity. What is added in this, we get the additive identity. For the in general, the real numbers. For real numbers, if we what we should be added in A, the real number, so that we get the additive identity. So what should be it? It should be minus A. So if A is minus A is added to A, we get an additive identity. So this minus A is called the additive inverse of A. So this is the basic concept for applied for the real numbers, and you are familiar with it. The same concept is here. Suppose A is a matrix, given matrix of order m by n, then minus A given by minus Aij having the same order m by n, and it is such that A plus minus A, that is equal to 0. 0 is the additive identity, that is equal to minus A plus A. Then this minus A is called the additive inverse of A. So this is all the properties we had seen here. So first is commutativity, second is associativity, third is existence of additive identity, and the fourth is existence of additive inverse. Thank you.